Friends, welcome to Eco Engineer YouTube channel. Today we discuss about uniform density function. Uniform density function. The uniform probability density function is defined as small fx of x is equal to this. Then the function is defined like this: fx of x is equal to 1 by b minus a less than or equal to x less than or equal to b, 0 elsewhere. Uniform density function formula: fx of small fx of x is equal to 1 by b minus a less than or equal to x less than or equal to b, where 0 is otherwise there is 0, where a and b are real constants. A and b are the real constants. Minus infinity less than or equal to a less than or equal to infinity. Minus infinity less than a less than infinity. B is greater than of a. The uniform distribution function is capital fx of x is equal to integral a to x small fx of x dx. The uniform distribution function is represents as capital fx of x is equal to integral a to x integral a to x fx of x dx. Fx of x is equal to integral a to x. Fx of x is nothing but 1 by b minus a dx is equal to x minus a by b minus a. Now capital fx of a is equal to 0 because of when I am substituting a in the x value, the capital fx of a is equal to 0. Capital fx of b, when you substitute the value x plus value b minus a by b minus a value is 1. Therefore capital fx of x is equal to, when the 0 x is greater than a, when 0 x is greater than of a, x minus a by b minus a less than or equal to x less than or equal to b, when value 1 x is greater than or equal to b. This is a uniform density function of shows the uniform probability density function distribution function. What is the probability density function of a density function? Here a and b from the 1 by b minus of a, small fx of x is called as density function. A and b in this x direction. Uniformly probability density function. The uniformly probability distribution function is like that. When the distribution function, the diagonal must be given from the point to the peak of the point. The point is 1.0. The x-axis and the capital fx of x. This is called as uniform probability distribution function. This diagram shows the uniform probability density function. Now the uniform probability density function has a constant amplitude in the given range. There is a constant amplitude in the given range, and the total area of the function is always 1. The total area of this function is always 1. This is called uniform probability density function. Now we discuss applications of uniform density function. Applications those are the random distribution of errors introduced in the round of process are uniformly distributed. The random distribution of error introduced in the round of process are uniformly distributed. In digital communication, when a sample of the signal is rounded off to its nearest level, or in a game when a real number is converted into an integer, the PDF of errors are uniformly distributed. The first application is the random distribution of error introduced in the random round of process are uniformly distributed. Now second one, the digital communication, when a sample of the signal is rounded off its nearest level, or in a game when the real number is converted into an integer. Whenever the real number is converted into integer, the PDF of errors probability density function of errors are uniformly distributed. These are the applications of uniform density functions. Thank you friends, thank you very much.